Okay, so in this video we've already learned how to do most of the quadratic stuff that we're going to learn, and we're going to try to apply those to some word problems to see how they can be used in the real world. So we've learned about vertex form, factored form, and standard form, or general form, and different forms will be useful to find different things. So in this problem it says, an object is launched at a certain velocity from a certain height. The equation for the object's height s as a time t is s of t equals negative 4.9 t squared plus 19.6 t plus 58.8. So this s of t right here is the height, and t is the time. So you can see right away that if you plug in t equals 0, this term is gone, this term is gone, because t is 0 and t is 0. So 58.8 is the height. So then the height is 58, and that's what it tells you in the problem. The object's starting height is launched from this height. So the starting height is where it's launched from, is what you get when you plug in t equals 0. So that should make good sense. 58.8. And then the starting velocity, 19.6 meters per second, ends up being right here in the middle of the equation as the starting velocity. And I can't necessarily show you easily why that's the case, but that's always going to be the case. The starting velocity will be here, and the starting height will be here. And then this first term comes from the acceleration, which is the force of gravity, and it's acting on all objects, pulling them downward. So the parabola is negative. So any kind of projectile motion problem is going to make a parabola that's upside down, because when you throw something up, the force of gravity is pulling it back down. So this question is, when does the object strike the ground? Well, it started 58.8 meters high. So if we were to look at this on a coordinate system, the y-axis, let me draw this all the way down here. It starts like 58.8 meters high, and it's launched upward. So it's going to keep going up a little bit more and then come back down. So we anticipate over here it's going to hit the ground at some time later. And we also anticipate there's going to be some negative answer where it wasn't actually necessarily at the ground right here, but if we draw the parabola does intersect the axis right here. But this is the solution that we want. So the real problem becomes, what is the height over here? Well, since it's hitting the ground, we want the height equal to 0, and in this case height is s of t. So we want s of t equal to 0. And if we plug in a 0 right here, we have 0 equals all this stuff, and then we have a quadratic equation, and there's different ways that we can solve it. So negative 4.9 t squared plus 19.6 t plus 58.8. So there's a couple different ways you can solve a quadratic that's in standard form when you're trying to find the zeros. One of the ways is completing the square, one of the ways is factoring, and one of the ways is the quadratic formula. So when you look at this, completing the square doesn't necessarily look like that good of an idea, whereas the quadratic formula, we can easily identify our a value, our b value, and our c value. But on the other hand, it might be worth trying to factor first just to see if it is factorable. A lot of times when you get problems in textbooks, the numbers are nice and they're all going to work out perfectly, and so factoring is a good idea. When you're getting problems in the real world, it's not as frequent that they'll work out nicely. But we have a negative 4.9 here that we could try to factor out of this term and this term. So let's see if these two terms are divisible by 4.9. The first one, 19.6 divided by 4.9, it is exactly factorable, and we get a negative 4. So if we factor out a negative 4.9, we would be left behind with t squared minus 4t. Notice it's negative because we factored out a negative from a positive, so we're left with negative. And then minus 58.8, 58.5 divided by 4.9 is, did I copy it down wrong? I did copy it down wrong, 58.8. Okay, and that's exactly 12. So it turned out that it was factorable, and now we have 0 equals this stuff, and we can further factor this part by looking for two numbers that multiply to negative 12 and add up to negative 4, and you should be able to see right away that that's going to be t minus 6 and t plus 2, and we still have the negative 4.9 and 0. So our solutions here are going to be t equals 6 and t equals negative 2, which are exactly what our graph shows us. Maybe not the numerical values, but the concept. Here we have a positive value, here we have a negative value. So t equals 6, and the units here are 6 seconds because everything has been meters per second and time is measured in seconds. So 6 seconds after the launch, it'll go up and then come back down and land right here. Starting at a height of 58.8 and ending at a height of 0. So I hope this shows you just one way that you can apply these kind of problems. Another thing you could have done is quadratic formula, using these 4 numbers. If you didn't realize that it was factorable, that this 4.9 could be factored out, that would absolutely work. You'd just be dealing with tough numbers. So let's look at one more example. So in the previous problem, they gave you the equation, but now, in general, the height of any projectile that's being launched is negative 16t squared plus the initial velocity times t plus the initial height. Now, in the previous problem, this was a 4.9. If you're measuring things in meters per second, then the value here is 4.9. If you're measuring it in feet per second, it's 16. And it's because there's a conversion factor between feet and meters of around 3.1, something like that. So the number is about 3.1 times larger. Okay, so an object is launched directly upward at 64 feet per second. So that's your velocity, 64 feet per second. And it's going upward, which will be positive. So this will plug in as positive 64 from a platform that's 80 feet high. So the height is starting off at 80. So our height, as a function of t, is going to be negative 16t squared plus 64t plus 80. Okay, so we plugged in all the information. And now the question is, what will be the object's maximum height and when will it attain this height? So again, let's kind of visualize on a coordinate system here. It starts off 80 feet high, so somewhere like this, and it's launched upward, so it's going to go up and then come back down. So the parabola looks very, very similar to the one that we had on the previous problem. And the highest point that it gets to is going to be right here. And you notice that this highest point is actually the vertex. So the question is, what will the highest point be? So we can find the y value for the maximum height. And when will that happen? That's going to be the x value for the time that happens. So what we really need to find is we need to find this vertex. The x and y coordinates will give us the maximum height and the time it took to get there. So if you're trying to find the vertex of an equation like this, you have some options. You could do completing the square, or you can do some kind of shortcuts, or you could find the roots first and then realize that the vertex is halfway between the roots. Those are all different options. The quickest method seems to be that we can use the shortcut that the x coordinate of the vertex is negative b over 2a, and we have these values a and b here and here. So negative b is going to be negative 64 over 2a is going to be 2 times the a value is the coefficient in front of the front, negative 16. And negative 64 over negative 32 is positive 2. So it's important that we make sure that this matches up with our graph. Yes, it is reasonable that it comes out positive because it's going up first. So positive 2. And then the y-coordinate of the vertex, we can plug this value back into our equation. So we have negative 16 times 2 squared right here plus 64 times 2 plus 80. Okay, make sure we follow PEMDAS on this first part. We multiplied the 2 squared before we multiply it by the 16. So 2 squared is 4, and 4 times 16 is 64. But remember that's negative because the negative sign. Then we have here plus 64 times 2 is 128 plus 80. And if you add those three things together in a calculator, you get 64 plus 80 is 144 feet. So this is your max height because it's the y value. It's the y value right here of the vertex, which is the highest it goes. And then the time equals 2 seconds because our x value right here of the vertex was 2. So projectile motion is just one of many examples where you see parabolic motion in real life. And you can use these quadratic equations and then all the different tips and techniques that we learned how to solve them to find things like max height, time to get to the top, or time to fall. You could also find how far it went. You could find out the velocity it's going at different positions, things like that. So projectile motion is a really easy way to visualize parabolas and think about what kind of parameters that they'll have.